Hello everyone, welcome to Life on Planet Earth. This is chapter 2 of this course. This chapter will focus on ecology and populations. Now, as a word of introduction, the picture that you see here, it's that of a lionfish. A lionfish is actually typically native to Indian Ocean and the Pacific Ocean, right? This is where these organisms occur naturally. However, this organism was discovered in the Atlantic Ocean around 1985. Since then, there has been an explosion in the population of this fish, the lionfish, right? Why is that explosion of the population of this organism? Because the lionfish doesn't have a natural predator in the Atlantic Ocean, which is a problem. So as we go through this chapter, I want you to focus on a few things. Why are introduced species more successful in their known environment, right? When it comes to population growth, do growth models that we apply with all living organisms also apply to human population, right? So these are a few things I would like you to focus on. All right. So we are going to dive in ecology, basically the science of ecology. We're going to look at the human population. We're going to study the characteristics of population. And we are going to conclude this chapter with life history patterns and extinctions of living systems. All right. First stop, it's going to be to define ecology. What is ecology? Ecology is the discipline that studies living organisms as these living organisms interact with each other and with their environment, right? Now, there are different levels of study of ecology, right? We can study ecology at organism level. At organism level, we are going to ask the following question. When we consider a clownfish, right, Nemo? When we consider a clownfish, how is the clownfish reacting in its natural habitat? What does the clownfish need? How is the clownfish responding to changes in the environment? Then we are going to ask the following question. How are clownfishes interacting with each other? Right? How are clownfishes interacting with each other? So now, first we were at the organism level. Now we are going at a population level, because now we are not just looking at one single organism. Now we are looking at the group, right, of the clownfishes, right? So when we look at just the organism, this is organismal ecology. When we look at a particular group of organisms that belong to the same species, now we are dealing with population ecology. And we can zoom out and look a little more of how the species of clownfishes is interacting with other species, for instance, the corals, right, in the coral reef, right? How are they interacting with other living organisms, the sea anemone, for instance, right? This is community ecology. And from community ecology, we are going to ask now, when we consider the coral reef, right? it's a huge group of different organisms, different species living together. How are they interacting with each other? And how are they interacting with the non-living component of their immediate environment? At that point, we are in ecosystems, right? We are studying ecosystem, okay? So we have community ecology and then ecosystems. And all ecosystems on Earth are going to constitute the biosphere. So these are the different levels of ecology that we can study, right? So ecology, it's a discipline that allows us to understand how living organisms interact with each other and are adapted to their environment. What is the influence of environment on their life, right? So ecology requires observation, okay? It also requires experimentation, right? Which means it's a whole science. You have to be able to apply the scientific method as an ecologist, right? We can, for instance, try to understand, for the case of this forest here, that forest that is composed of lodgepole pine trees, right? We can ask, what is the effect of the lodgepole, what is the effect of fire on the composition of lodgepole pine forest? And as we have that question, what are we going to do? Well, we're going to determine a particular piece of the forest, and we are going to say, well, let's set a fire in this forest, and let's see how the forest is going to recover over time. So here you have a forest that has been burned down, and B, we have how the forest is recovering over time. And we get to understand that some forests actually require wildfire for them to thrive, for this forest to thrive. They need that wildfire to actually reset a number of aspects in their environment so that life can thrive, right? It may sound weird, but that is the very case when it comes to the lodgepole pine forest. All right. Now, ecology has different components, including environmental science. Environmental science, it's basically the application of ecological principle to practical problems that human is encountering, right? So this means that with environmental science, we are going to draw our interest on the management, on the management of resources and the stewardship of resources. For instance, how are we going to do logging? How are we going to do fishing, hunting, and so on and so forth? When are we going to hunt deers, right? Are we going to hunt them at all, right? How about ducks? How about boars, right? How about rabbits, okay? And then we have conservation biology. Conservation biology, it's a discipline of ecology that studies all aspects of biodiversity. How do we go about preserving living systems around us, right? We know that living systems interact with each other, but they also interact with their environment, right? We have to study all of that. What is sustainable? What is not sustainable, right? So we're going to try to conserve our natural environment. For instance, the forest where I'm sitting right now, it's a preserved area, right? So someone cannot just come and say, well, we are going to build a mall here. That is not going to happen, right? Because in conservation biology, we've said that, well, you know what? This area is designated preserved, a nature preserved, right? This is really cool because now, well, we can build houses in some places, but we can also leave some areas for deers, rabbits, squirrels to thrive, right? Monkeys, gorillas, and so on and so forth, right? So, wildlife is an integral part of our biosphere. Without preserving that wildlife, even our very own existence is going to be threatened. That is the very reason why, by the way, the quality of life is going to decrease tremendously in major cities where you have a lot of pollution, as opposition to the countryside where air is very clean and good to breathe. All right, so at this point we are going to dive in population, and specifically dive in human population. Well, human population has tremendously changed over the past. How so? Well, for a long time, the human population, while it was growing, the growth was not exponential, right? The growth was relatively modest. But because of a number of things, including technology, the improvement of medical conditions, now we can maintain people in life for a long period of time, but also provide them with a good quality of life, right? So now there are a few things I would like to mention. Now on this particular curve here, you have a dip right here that happened around the 14th century. In the 14th century, there was a black plague that actually decimated a huge population in Europe. Then we had the Industrial Revolution in the 18th century. In the 19th century. The Industrial Revolution actually changed tremendously the quality of life of humans. Therefore, the quality of, the human population started increasing. And now, with modern science and medicine, the population has exploded tremendously, right? We have an exponential growth. And actually here, we see that, well, that population growth is going to continue, but eventually, that population is going to level off, right? Where is that population exactly going to level off? We don't know exactly. There are some assumptions as to where and when the human population is going to level off, but we don't know for sure, right? We talk about, the carrying capacity of Earth. Some people think that we are approaching the carrying capacity of Earth because at this point on Earth, we are about, if my memory is good, 8.1 billions of people, right? So when are we going to reach the carrying capacity on Earth? We don't know. But there are some assumptions that it can be maybe 2050, but it's only assumption, okay? Now, when we talk about human population growth, there are a few things we have to take into account. One is the growth rate, okay? That growth rate, it's actually a combination of two factors: the number of births and the number of deaths. So to determine the growth rate, we are going to subtract out of the number of births, we are going to subtract the number of deaths, right, for a given year. So specifically, here we have an example. If for a given year, the population, the birth rate in the population was 18.5%, and the death rate was 7.8%, right? We're going to divide this by 1,000 for every 1,000 people, right? So this is basically 10.7 divided by 1,000, right? This is 0.0107 times 100. This is 1.07%. That's the growth rate of the population for this birth number and death number, right? Or death rate and birth rate. All right. So birth rate and death rate vary tremendously from one country to another, from one continent to another. In 2017 projections, right, we're going to take a look at some countries in the world and some places in the world, right? The birth rate in Nigeria was about 6.2 per woman, while in Singapore the birth rate I'm sorry. Okay, so the human population growth. For the human population growth, the birth rate and the death rate are going to vary tremendously from one population to another population, from one continent to another continent. In 2017, there was a projection. That projection shows that the birth rate in Nigeria, for instance, was 6.2 child per woman, while in Singapore, that birth rate was 0.83 child per woman. Then the death rate was 19.3 per 1,000 individual in South Sudan, while that death rate was 1.6 for 1,000 people in Qatar. The annual growth rate in Syria was 7.37%, while in South Sudan it was 1.16%. In the US, the birth rate in 2017 actually was 1.87 child per woman. The death rate was 8.2 for every 1,000 individual. The annual growth rate in the United States in 2017 was 0.82, right? So these numbers actually show you that there is a tremendous variation from one country to another when it comes to growth rate, birth rate, death rate, and even annual rate. All right. So with population growth, we have to think of a certain number of things, including managing the resources. Do we have the amount of food that is needed to sustain the population that is growing? Do we have the amount of water that is needed? Do we have the amount of energy, right? Do we have the amount of shelter? Do we have the amount of land? And so on and so forth. But what is for sure, it's that there is a variation in population growth per area of the globe. We have areas that are more developed countries, we have areas that are less developed countries. In any way, what I want you to remember is that there is a rapid growth decline when food becomes scarce. Okay? That growth decline also occurs where space is becoming scarce, so that when we study population, we have to think of the concept called the carrying capacity. That carrying capacity, it's for a given geographical area, the resources that are needed to maintain a healthy population. A given area has a carrying capacity. Once you reach that capacity, the population cannot grow anymore. Okay? The population is going to level off. So the projection of human population across the globe, it's that in regions such as Africa and India and Asia, we are going to see some growth in the population, while in some areas like the old world in Europe, in some areas in Asia, the population is not going to grow that much, right? All areas that are blue are areas where populations are not going to grow much, while areas that are orange-ish are the areas where populations are going to grow tremendously. Now, let's compare more developed countries and less developed countries. In more developed countries, including North America and Europe, the population growth is relatively modest, right? People are going to enjoy a fairly good standard of living, right? Now, when we look at less developed countries, however, including Latin America, Asia, and Africa, population growth is tremendous, right? We see that the majority of people are going to live in poverty because there is a lot of competition, right? A lot of competition for resources, right? But quite frankly, there are also other reasons, right? There are also other reasons. But let's close that parenthesis. We don't want to get into the politics, right? We want to stay 100% biology and how, population is being affected. In more developed countries, the population was not always declining as we see today. There were times when populations were really high. For instance, when Europeans started leaving Europe. Why did they start leaving Europe? They started leaving Europe because there was a high competition for resources, right? The population was humongous, so that resources were becoming scarce and competition was high. So to alleviate that, Europeans started traveling abroad, including in Africa, in Asia, in India, and places like the New World in the Americas, right? We see, for instance, that between the year 1850 and the year 1950, this is about a century, the population doubled, right? That population doubled because of an increase in birth rate and a decrease in death rate, right? So the population in more developed countries, though, went through a transition, so that overall today the growth rate is very low. It's about 0.1%. Now, while that growth rate is being low, when we consider the US population, though, the growth rate in the US population is 0.8, almost 1%, right? Which means that the US population is still growing. right? In spite of the control, right, the population is still growing. Now, in less developed countries, we do see a declining death rate for an increased birth rate. This causes an overall increase in the population growth, right? It causes an overall increase in the population growth. So it is believed that by year 2050, the population will reach about 8 billion people, right? 12 of the most populated cities in the world are going to be in Asia. With a constantly increasing population in the world, we have to think about resources and the consequences of, you know, all the resources that we are using and how we are using them on our environment. So we will have to think about pollution. The water crisis. Are we going to have enough water to sustain all these people, right? How about wildlife? Are we going to be able to preserve that wildlife, or are we going to lose that wildlife? When we compare the structure of ages between more developed countries and less developed countries, we notice that, well, this age structure is going to actually vary tremendously between these two groups. Now, looking at the age structure, we can divide a population into 3 subgroups. These 3 subgroups are going to include the pre-reproductive ages, right? The pre-reproductive ages. The second subgroup is going to be the reproductive ages. And the third subgroup is going to be the post-reproductive ages. For all population in the world and in all countries, this is how we are going to divide the population. And then we are going to ask the following question: how many people do we have in the pre-reproductive age? How many people do we have in a reproductive age and in a post-reproductive age? Now, what we notice is that in less developed countries, we're going to have a broad base, meaning that the people in pre-reproductive age are going to be more abundant than anyone else in the population, followed by the reproductive age people, right, with a very narrow post-reproductive group of population. Now, when we compare now with more developed countries, we have a pre-reproductive age of population that is very narrow, right? Actually less than the reproductive age group, and the post-reproductive age group is also narrow, which means that actually less than one adult, less than one child is going to exist for every single adult. This is the characteristic of a declining population. Okay, while in a more developed, in less developed countries, we have multiple children per one adult in a reproductive group, which means that this population will keep increasing because the children who are now children are going to become adult and enter the age of reproduction, and the population will explode over time. But the question that is fair to ask is that, will the population among humans keep increasing at the pace it is increasing now because of the conditions where we have a plenty of food, we have a good health system, where we can keep people alive, when we can actually reduce the post-birth death, right?